Hello students, welcome to my YouTube channel Pratik Singh classes. In this video we are going to study standard 9 science chapter 1 matter in our surroundings. We will see here three sections. Section 1.4.2 that is about effect of change of pressure. In our previous video, in video number 3, we have studied that when changes happens in temperature, what happens to the state of matter, and this is the next part of the same chapter of the same topic, that is effect of pressure on state of matter. Okay, then the new topic will start, section 1.5, that is about evaporation. You will see what is the definition of evaporation, what happens in evaporation. Okay, then what are the factors affecting evaporation. Section 1.5.1 we will see. Okay, this is the fourth video of first chapter. Okay, if you have missed my 3 videos, I will add a card. Okay, if you touch the top right corner of your mobile screen, okay, it will show you the links of the previous video. If you touch it, okay, it will take you to the previous videos where you can watch all those things. If you are new to my channel, please subscribe it now. Please like and share the video to your friends so that everybody should get benefits from my knowledge. Okay, please hit the bell icon so that whenever I will upload a new video, you will get its instant notification. In your Chrome browser or Google browser or any browser which you use, okay, like Safari, Mozilla, just type youtube.com/c/Pratik Singh classes and it will take you to the all of the tutorial videos which I have made at one place. That is the link of my YouTube channel. Fine, so let us start our today's video. Okay, section 1.4.2 effect of change of pressure. Alright, so let us start our today's class. The topic is effect of change of pressure. In our previous video we have studied about can matter change its state, and a lot of other things we have seen related to what happens when we change the temperature of the matter, okay, and how does the matter changes its state. Then we have also seen that when matter changes its state, what happens to the particles of the matter. Fine, okay, so those things were related to heat. Now today we will study things related to pressure. We have already learned that the difference in various states of matter is due to the difference in the distances between the constituent particles. Okay, so we know very well that if in any matter, okay, if the distance between the particles is very less, it will be solid. If further the distance will increase, it will be liquid, and if the distance between the constituent particles are very high, okay, it will be in gaseous state. Okay, fine. Okay, what will happen when we start putting pressure and compress a gas? Okay, later we will see here, enclosed in a cylinder. Okay, as you can see here in figure 1.8, okay, it is a cylinder and some gas is filled inside and it is compressed by piston. Okay, when we compress the piston, means when the piston moves inside or downwards, the volume decreases, and further more volume has decreased when we have increased the pressure furthermore. Okay, so what really happens here is when we increase the pressure, volume decreases, but keep in mind the weight will remain the same. Okay, will the particles come closer? Okay, what will happen here? As you can see in figure 1.8 A, B and C, the particles have come closer to each other. So yes, the particles will come to each other. Do you think that increasing or decreasing the pressure can change the state of matter? About this thing we will see right now. So what really happens when we increase the pressure, okay, and whether the state of the matter changes. Okay, just take an example. The cooking gas cylinders which we use in our kitchen, okay, the gas is filled there at a very high temperature, and because of the high temperature, the material filled inside stays in liquid form. Okay, so there, because of very high pressure, the gas converts into liquid. But here we will see what really happens here. Applying pressure and reducing temperature can liquefy gases. Means if we do these things simultaneously together, means if we apply pressure, means if we increase the pressure at the same time we decrease the temperature, the gas will become liquid. Okay, so there will happen a change in state. Have you heard of solid carbon dioxide, CO2? Okay, this is also called as dry ice. Okay, it is stored under high pressure. Solid carbon dioxide gets converted directly to gaseous state on decrease of pressure to 1 atmosphere without coming to liquid state. Okay, and because solid carbon dioxide converts directly into gas, okay, that is why it is also called as dry ice. It doesn't give any kind of liquid. This is the reason that solid carbon dioxide is also known as dry ice. Okay, as I have said you earlier. Fine. Thus, we can say that pressure and temperature determine the state of a substance, whether it will be solid, liquid or gas. Okay, that means if we change the temperature, the state of the matter will change, as we have seen in our previous class, as well as if we change the temperature also, the state of the matter will change. Okay, so as you can see here, when solid changes to gas, it is called as vaporization, but its opposite, gases changes to solid, is called as condensation. Okay, this vaporization and condensation may happen because of change in heat or change in pressure or both. Likewise, gases changes into solid, and this process is called as deposition. Solids changes into gas is called as sublimation. Okay, likewise here it is given solid converting into liquid is called as fusion, and the process by which liquid changes into solid is called as solidification. Okay, so all these things, the change in the state of matter, okay, may happen because of changing the temperature or changing the pressure or both. Okay, here as you have seen, one star mark was given. Where was that? Let me see, let me check once again. Yes, here. Okay, let me delete this. See here, 1 atmosphere, a star mark is given. What is the meaning of 1 atmosphere? It is given here. Atmosphere, or it is also abbreviated as ATM. Okay, it is not your ATM machine, it is atmosphere, is a unit of measuring pressure exerted by a gas. The unit of pressure is Pascal. Okay, and 1 atmosphere is equal to 1.01 into 10 to the power of 5 Pascal. So this is a very huge, very high quantity. The pressure of air in atmosphere is called atmospheric pressure. Means the pressure exerted by the air on our body is called as atmospheric pressure. Okay, and because of the atmospheric pressure, our blood circulations remain at its pace. The atmospheric pressure at sea level is taken as 1 atmosphere, and as we move above the surface of earth, the atmospheric pressure decreases and is taken as the normal atmospheric pressure. Means the pressure on the surface of sea level is called as 1 atmosphere, and that is taken as 1 normal atmospheric pressure. Alright, fine. Now this thing has completed. Coming to next section, that is section 1.5, evaporation. Okay, what do you mean by evaporation? What really happens when any matter evaporates or any liquid or evaporates? Okay, then during evaporation, what happens to the particles of the matter, and a lot of more phenomena to understand here. All right, so let us start section 1.5. We already have seen water boiling, and when the water boils, it evaporates. Okay, then a lot of other phenomena we have seen. The water cycle happens because of evaporation. When the sun hits the water present in the water bodies like sea, ocean, rivers, dams, okay, evaporation happens, and because of that evaporation, when vapors condense, it makes cloud, and clouds again rains back to the earth, and that cycle goes on and called as water cycle. Okay, so here we will see all the other things. Do we always need to heat or change pressure for changing the state of matter? Okay, as earlier we have seen, okay, as we have seen here in this figure 1.9, different processes of change of matter and different processes names we have seen here. Okay, now the question arises here is, to change the state of matter, do we always need to change the pressure, or do we always need to change the heat? Okay, change the temperature. Is it possible that without changing the pressure or without changing temperature, evaporation may happen? So let us see these things. Can you quote some examples from everyday life where change of state from liquid to vapor takes place without the liquid reaching the boiling point. Okay, means before coming to the boiling point, is it possible that the liquid evaporate? Okay, yes, it happens. See, if you boil the water, okay, below 100 degrees Celsius, the boiling point of water is 100 degrees Celsius, but even at 40 degrees Celsius, water evaporates. Even if you see ice, some amount of fog comes out of ice. That means evaporation happens at every temperature. Okay, let us see what is given here in the book. Water when left uncovered slowly changes into vapor. Okay, just take an example. Take a beaker, okay, or from your kitchen take a glass or any vessel whose mouth is wide open. Fill that with water and keep that into dark place or any place untouched it. Okay, after some times, after some hours, we see that the water level has decreased. That means some amount of water has evaporated out. Okay, then wet cloths dry up. When we wash our clothes and rinse water and then we hang the clothes, okay, we see that the wet cloths dry up. Okay, what happens to water in the above two examples? Means when the clothes dry up, what happens to the water present in it, and when the water which we have kept in a vessel and without heating it, its amount has decreased. So what really has happened to the water? Where has that water gone? We know that particles of matter are always moving and are never at rest. Whether it is solid or liquid or gas, particles of matter are always moving. But the only difference is that if the matter is in solid state, the movement of particles will be limited, means very short distance. If it is in liquid state, the force of attraction between the particles will be lesser than that in solid, and so they will move fastly. And in gaseous state, the force of attraction between the particles are so negligible that they move away from each other. Okay. At a given temperature in any gas, liquid or solid, there are particles with different amounts of kinetic energy. Okay, means any material, okay, even in same state but at different temperature, they will have different amount of kinetic energy. Okay. Fine. In case of liquids, a small fraction of particles at the surface having higher kinetic energy is able to break away from the forces of attraction of other particles and get converted into vapor. Okay, so let me draw a figure for you for a clear visualization. Okay, so just suppose you have a vessel and in the vessel liquid is filled. Okay, the upper layer of the liquid will be at higher temperature, and when because of that higher temperature, that liquid will be at higher kinetic energy, and because of that higher kinetic energy, the upper layer of the liquid will evaporate fastly, okay, and will convert into vapor. This phenomenon of change of liquid into vapor at any temperature below its boiling point is called evaporation. Okay, so now you have understood that evaporation may happen at any temperature, but the boiling point is fixed. Okay, fine. Now coming to section 1.5.1, factors affecting evaporation. Okay, so let me ask a question first. Will change in temperature affect evaporation, or will change in pressure affect evaporation, or both? Okay, changing of pressure and temperature will change the rate of evaporation. Fine. So let us try to do this activity 1.14. Take 5 milliliter of water in a test tube and keep it near a window or under a fan. Okay, so just do this in your physics lab or in chemistry lab. There you will get test tube, and in the test tube pour 5 ml of water and without disturbing it, keep it under a fan or near a window. Take 5 ml of water in an open china dish and keep it near a window or under a fan. Okay, so take another pan, okay, and same amount of water is poured in that pan and kept near the same place, okay, near the window or under a fan. Now take 5 milliliter of water in an open china dish and keep it inside a cupboard or on a shelf in your class. Okay, so here we have taken 3 vessels. In first we have taken 5 ml of water in a test tube, okay, and kept that near the window or under the fan. In second we have taken a china dish, poured 5 ml of water and again kept it in open area under fan or near the window. And the third situation, we have taken 5 ml of water and poured that water in a china dish and kept that in a closed area, okay, here as given cupboard, which is a closed area. Fine. Record the time or days taken for the evaporation of process in the above cases. Okay, so find out that in your observation that how much time is taken for the water to be completely evaporated in all the 3 processes, in all the 3 experiments, observations. You will find out that when you have kept the china dish near open window or under the fan, the water present there has evaporated very fastly. Okay, then the second one is the test tube. When test tube was kept near the window or under the fan, when its mouth was open, water has evaporated but lesser than the open china dish. And the third one, okay, when the china dish was kept inside the cupboard, because there happened no flow of air, okay, it has taken long time for all the water to get evaporated. Repeat the above 3 steps of activity in a rainy day and record your observations. In rainy days, what will happen here is the time of water to get evaporated will become higher than the earlier. Okay, so what is the difference in the normal day and rainy day? In rainy day, the content of water vapor in air is already very high. Okay, so there is very less chance of water to be get accumulated in air. Okay, what do you infer about the effect of temperature, surface area and wind velocity or speed on evaporation? Okay, we have seen when we have open surface, water has evaporated very fastly. When we had closed surface or closed area, or when the wind is not blowing fastly, okay, the evaporation time was higher. Okay, you must have observed that the rate of evaporation increases with, okay, here in this above observation activity 1.14, we come to the following results. An increase of surface area. Okay, surface area means test tube and china dish both have different surface area. Surface area of china dish was far bigger, far more than that of open surface area of that test tube. We know that evaporation is a surface phenomenon. That means evaporation always happens on the surface. If the surface area is increased, the rate of evaporation increases. Means higher will be the surface area, higher will be the rate of evaporation. For example, while putting clothes for drying up, we spread them out. Okay, means if you spread the clothes, okay, it will the water in that cloth, okay, will evaporate fastly rather than if you keep the wet clothes crumbled. Okay, what happens when temperature increases? What is the effect of increase in temperature to evaporation? All right, fine. With the increase of temperature, more number of particles get enough kinetic energy to get into vapor state. Means when we increase the temperature of water or any liquid, its kinetic energy increases, and when the kinetic energy increases, higher will be the kinetic energy, higher will be the rate of evaporation. Fine. Now a decrease in humidity. Humidity means the amount of water vapor content in air. Humidity is the amount of water vapor present in air. Okay, the air around us cannot hold more than a definite amount of water vapor at a given temperature. Means at given temperature there is a limit that how much amount of water vapor can be mixed into air. Fine. If the amount of water in air is already high, the rate of evaporation decreases. That is why during rainy season the cloth which is wet dries up very slowly. Okay, but in summer season when the vapor content in water is very less, okay, the cloth dries up fastly. Okay, an increase in wind speed. Okay, in our previous activity we have seen that when we have kept the china dish inside the cupboard, okay, and other china dish outside the cupboard in open area, okay, that china dish which was in open area, the water evaporated fastly than that china dish which was inside the cupboard. Okay, that means if the wind speed will increase, the rate of evaporation will increase. Coming to the context of book, it is a common observation that clothes dry faster on a windy day. Means if the wind is blowing fastly, the clothes will dry up fastly. Okay. With the increase in wind speed, the particles of water vapor move away with the wind fastly. Okay, that decreasing the amount of water vapor in the surrounding. Okay, so this is the reason why the wind higher will be the wind speed, higher will be the rate of evaporation. Fine. So this is all about section 1.5.1 factors affecting evaporation. Now let us start section 1.5.2, that is how does evaporation cause cooling. Okay, during summer days when you become full of perspirations, sweatings, and when you sit under a fan running, okay, you feel cool. And the perspiration dries up fastly. Okay, is it possible that the drying up of sweating has made you feel cool? Okay, we will see here. Does evaporation cause cooling? In an open vessel, the liquid keeps on evaporating, as we have seen in previous activity. Okay, the particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. Okay, what is given here is when the liquid is kept in open region, okay, in open area, okay, the particles of the liquid, it absorbs energy from the surrounding, and because of that absorption of energy, the kinetic energy increases. Okay, and so they evaporate. This absorption of energy from the surroundings makes the surrounding cool. And what happens there is, because the liquid is absorbing heat from the surrounding, the temperature of the surrounding will drop down and the surrounding will become cold. That is why when we sit under a fan, okay, the perspiration takes heat from our body for evaporation, and when they take out heat from our body, we feel cool, because at that time till the evaporation happens from our body, okay, the temperature lowers down than the surrounding and we feel cool. Okay, what happens when you pour some acetone, that is nail polish remover, on your palm? We feel cool. Why do we feel cool when these types of material come in contact with our body? What really happens there is, the particles gain energy. That acetone gains energy from our palm, our body, okay, or the surroundings, and evaporate, causing the palm to feel cool. Means when we pour the acetone on our hand, acetone takes heat from our hand and evaporates, because there happens loss of heat. Okay, heat flows from our body to the acetone. Okay, the temperature of the region which is in contact with acetone comes down the surrounding, and we feel cool in that region. After a hot summer day, people sprinkle water on the roof or open ground, because the large latent heat of vaporization of water helps to cool the hot surface. Okay, if you are living on the uppermost part of your building, okay, in uppermost floor of your building, okay, you might have done, or you might have seen somebody doing that. They sprinkle water in evening during summer day. Why do they do that? Because of doing that, the water which comes in contact with the hot floor, okay, they take the heat from the floor and evaporates, and when that happens, the temperature of the floor, or when we are inside, the temperature of the roof decreases, and inside the room we feel cool. Okay, can you cite some more examples from daily life where we can feel the effect of cooling due to evaporation? Okay, let me do this question for your homework. Okay, just comment the answer of this question in the comment box, and I will recheck and say the things whether you have done it correct or not with the reason. Why should we wear cotton clothes in summer? Okay, during summer season we wear cotton clothes, not the woolen clothes. Why? What is the reason? During summer we perspire more because the mechanism of our body which keeps us cool. Okay, higher will be the amount of water our body will lose, it will keep us cool. Okay, and during summer season the amount of perspiration is higher than in other season. We know that during evaporation the particles at the surface of the liquid gain energy from the surroundings or body surface and change into vapor. Means because of evaporation the particles takes energy from our body itself. The heat energy equal to the latent heat of vaporization is absorbed from the body, leaving the body cool. Okay, means the perspiration will take out energy from our body for perspiration, and because of that we feel cool. All right, cotton being a good absorber of water, okay, and which helps absorbing the sweat and exposing it to atmosphere for easy evaporation. And when evaporation happens fastly, okay, the exchange of heat happens fastly, and because of that we feel cool. Okay, fine. So this is about cooling. The next topic is, the next question is, why do we see water droplets on the outer surface of glass containing ice cold water? Okay, you might have seen that during summer season or any season when you keep a glass filled of cold water, okay, to the outer surface of the vessel or to the glass, okay, water droplets stick to that. What happens? From where has the water come? Whether that water has come from inside the vessel, from inside the glass? No, it has come from the atmosphere. Let us see how. What really happens there is, the ice cold water is in tumbler. Soon we will see water droplets on the outer surface of the tumbler. The water vapor present in air on coming in contact with the cold glass of water loses its energy and gets converted into liquid state, and which comes in the form of water droplets. Okay, so that is the reason that water droplets sticks to the cold surface. Okay, not only to glass, to any cold surface, any surface whose temperature is lesser than the atmospheric temperature or surrounding temperature. Okay, you can see that water droplets has stick to it, and that happens because the water vapor present in the atmosphere, when it comes to the contact of that surface, cools down and it loses its energy and comes back to liquid state. Okay, so this is all about unit 1. I hope you have learned a lot of things from this 4 video. Totally for this unit I have made 4 videos. This is the 4th one. Okay, I hope all of you have seen all the videos. If you have any doubt, if you have to ask any question, just type that question in the comment section and I will answer all of them. Okay, so in our next video we will see the question answers related to this question, okay, one by one with explanations. Okay, till the next video, take care of yourself. Bye bye.